Okay, this is obviously a circle theorems question. A, B, C, and D are points on a circle centre O, right. E, B, F is tangent to the circle at B, right. Work out the size of the angle DCB. Well, that's super easy, isn't it? Because it's opposite angles in the cyclic quadrilateral. This thing is a quadrilateral. It's cyclic because all of its points are on a circle. And the opposite angles, that and that, and that and that, sum to 180. So I know if this one's 40, that this one has to be 180 minus 40. So okay, so it's asking me in the second part, give me a reason. Quite often they ask you to give reasons. The first one just wants the answer. So I'm going to just make sure I put that down, 140. And that looks right, even though it's not accurately drawn. It's clearly an obtuse angle. And then in here I can just say opposite angles cyclic quad sum to 180. That'll do. Work out the size of angle ADO. ADO is this funny little angle here. Let's have a look. Well, I can work out this one very easily because angles subtended by the same arc are twice at the centre than they are at the edge. So by same arc, we mean this. This angle here is subtended by that arc at the edge, and this angle is subtended by that arc in the middle. So I know that this angle is 80, it's twice. Okay, the fact, I can see how this works. The fact that they've given me this thing here with this tangent says to me that they probably want something to do with the alternate segment theorem. Alternate segment theory says that for any cyclic triangle, for anything that a triangle that's inscribed within the circle, and I've kind of just made one there, the angle in the alternate segment here is, these angles are going to be equals. So this one I know is 66, this big one here. And that allows me to do some sums here because I've got a triangle, the triangle ODB, and I know that it's isosceles because it's got two radii there. Each of the two short sides are radii of the circle. So I know that each of these yeah, is that right? Yeah. So I know that these small angles here and here, I'll remove those, but each of those two angles has got to be 180, that's the angles in the triangle, minus 80 divided by 2. So each one of those is 50. And since I've got angle ADB being 66, I know that each one of those is 66. I know that ADO has got to be 66 minus 50, which is 16. So I'm going to show some working here because it's asking, it's 3 marks. So just putting the answer down I don't think is a tremendous idea. I'm going to say that DOB equals 80 degrees. And then I'm going to just note down twice at centre. I think that's enough. I know that ODB equals 180 minus 80 all over 2, and that's 50. and I can say that ADB, let's do that properly, ADB equals 66, and I'm just going to put AST there, alternate segment theorem. And that tells me therefore that ADO equals 66 minus 50 equals 16 degrees.